All right, everybody, and welcome to Investigation 7B. This investigation is actually very useful for people who are tornado chasing. Unfortunately, the examples that the textbook came up with weren't really interesting, but I'm still going to try to show you some really cool stuff about the technology here. So, in the last exercise, we talked a little bit about Doppler radar and how it's useful for finding precipitation. But Doppler radar also has another use. If you've ever lived anywhere and heard of a Doppler radar indicated tornado. Another thing that Doppler radar allows us to do is actually identify the location of tornadoes. And so I'm going to show how that works right now. So this lab's goals are first to identify where winds are traveling using a Doppler radar, and then construct a wind pattern using a Doppler radar map. So here's how it works. I'm going to have to switch here to some colors. So the way that it works is just like with precipitation, the radar sends out a pulse. That pulse then bounces off of raindrops and sends a return. And based on what direction the wind is blowing, that slightly changes the nature of the return. And so looking at how the return has changed can actually tell us where that raindrop is blowing and can actually give us a good indication of the wind. Now with that said, there are some problems with this. The only thing that it can actually tell us is if the raindrop is blowing towards the radar or away from the radar. It can't actually give us any horizontal movement, any other horizontal movement. So let me explain what I mean by that. So over here we have a radar, and we have 5 different beam positions. And the way it works is that any location where the wind is directly blowing towards the radar, like right here, we're going to shade in green. And if you notice that the radar beam and the direction that the wind are blowing are parallel to each other. They're in the opposite direction, but they're parallel to each other. And the wind is traveling directly towards the radar. And what happens is this is identified as a bright green, typically the fastest winds. Now with that said, locations like down here, where the wind is also blowing parallel to the beam, but is actually blowing away from the beam, this is actually an area that we would highlight in red. So this represents an area where the wind is actually traveling away from the radar station, and we would shade that in red. Now, if you actually look at radar beam position 3, you notice that here the wind is actually blowing perpendicular towards the radar, perpendicular from the radar, perpendicular from these beam positions. Well, the problem with this technology is it can't identify any motion that is perpendicular to the beam. It only identifies motion that is towards the beam or away from the beam. It cannot identify any motion that is perpendicular to the beam. So this is actually what we would call our zero line. Let me pull up another color here. I'm going to use blue. This right here is actually our zero line. And in fact, using the radar velocity, this would actually be seen as a region where there's no wind. Why? Because the radar cannot detect winds that are perpendicular to the beam. Now what about these other locations, like location 2 and location 4? So in these locations, in order for us to really get a feel for what's going on, we actually have to split the wind into individual, what are called vectors, individual components. And this wind right here is pointing down, but it's also pointing a little bit to the left. And what we do is we can actually break the wind down into that left component and into that down component. just like that. And if you notice, there is a little bit of a component that is actually pointing directly towards the radar. Since it's pointing towards the radar, we would highlight it in green. So right here, this is actually an area that would show up on a radar image as green. On the other hand, if I were to go to the other arrow, here at the same beam position, now the arrow is pointing up and to the left. I could split it up again into its two categories, up, into its two vectors, and to the left. And again, there's a component of this arrow that is pointing towards the radar. So again, I can highlight that in green. I can highlight that in green. On the other hand, down here at beam position 4, if I were to actually split the wind up into its individual components, there's the first one, there's the second one, and then over here, do the same thing. There's the first one, there's the second one. So now you're just splitting it up into its individual components, up and to the right, or down and to the right. In this case, or up here was up and to the left and down and to the left. So that's all you're doing you're splitting it into its even components, either up and to the left, down and to the right, or so on. And if you notice here, that component that is parallel to the beam is actually pointing away from the beam. So here we're going to highlight this in red. We're going to highlight this in red. And we're going to do the same thing here. Now actually what we end up seeing is a pretty interesting result. Everywhere between positions 1 and 3 is going to have at least some component of the wind that is blowing towards the radar. And so what we actually are going to do is we're going to shade this whole area here in green. And again, forgive me for how terrible my drawing looks. Ugh, okay, I messed up there. Let's erase just that. There we go. But I just shaded it, actually just that there. Ah, it all went away. Sorry. Let's do this again. We're just going to shade all of this in here in green. So all of this area contains winds that have at least some component that is blowing towards the radar. Meanwhile, down here, there's some component that's blowing away from the radar, and so down here, we're going to see a lot of red shading. A lot of red shading. So whenever you see green on one of these maps, that represents wind that has at least one component pointing towards the radar. Wherever you see red, so green, one component pointing towards the radar, red, a component pointing away from the radar. And these maps usually look something like this right here. So here we go. So this one is for Flagstaff, Arizona, and I actually put a star here where the location of the radar is. And then what you're going to do, and this is different from the one that you actually will see on the lab, because I didn't want to just give you the answers to that. The AMS people might not be happy about that. But what I'm actually going to do is draw a zero line right here. And now with that said, the wind pattern sometimes is going to look a little different than you would actually see it. That zero line might not be perfectly straight. But there's the zero line right now. And everything over here represents winds that are pointing at least somewhat towards this radar station. So the winds right here are pointing towards the radar station, like so. Meanwhile, over here, the winds are actually pointing away from the radar station, which, believe it or not, would also be like that. So the wind direction itself hasn't changed. The only thing that's changed is the direction relative to the wind. Or sorry, relative to the radar. I apologize for that. Relative to the radar. Over here, the winds were moving towards the radar. And then once they passed the radar, then they were moving away from it. Just like if you were walking towards me, but then you kept walking, now you're walking away from me. And what actually this book is going to want you to do, what this lab assignment is going to want you to do, is actually create a wind pattern, actually telling me, okay, how is the wind blowing? And what they're going to tell you to do is first come up with the zero line, just like I did, and then draw an arrow perpendicular to the zero line pointing towards the red. And so I'm going to do that right here, and that is my wind direction. Actually, I'll use black just because it will stand out better. There we go. And that is the wind direction. So that's what direction the wind is blowing towards. Now with that said, remember when you're looking at a station model, they're going to have you compare station models to what you came up with here. You're actually going to be comparing where the wind is coming from. So the wind is coming from, in this case, north is at the top. So the wind is actually coming from the southwest and it's blowing towards the northeast. Now the last thing that they're going to ask you is, where are the strongest winds here? And it's somewhat a trick question. And the reason why it's a trick question is because these radar beams actually point upwards. And the higher you go, the less friction there is. And as a result, the further out you go from the radar station, the brighter the reds are going to become because you're getting higher up, therefore you're going to see more wind speed. And then the same thing with the greens. The further away you get from the radar station, the higher the beam is actually going to be at and the faster the wind is going to look like. They typically aren't going to be as fast as what the actual surface observation is. So that's it for this exercise. Again, as always, questions, comments, concerns, please don't hesitate to reach out to me. All right? Good luck, and just let me know if you need any help.